Welcome to OOTO TV, the out-of-the-office investigation from the past into the future of marine navigation and autopilot technology. This time we're discussing requirement specification for marine navigation and piloting tool for both inshore and offshore global navigation.
That's right. We're diving into what absolutely must be in such a system today. Think high-level needs, drawing on tech advancements, but also, crucially, lessons from when things went wrong at sea.
And our focus today will cover, well, three main areas, won't it? We're looking at the user side, the audience needs, then the nuts and bolts, the technical capabilities.
And critically, safety and regulatory compliance. We'll be keeping a close eye on how real-time data gets handled and how the user actually experiences the system.
Okay, let's lay the groundwork. It's vital that the requirement specification for marine navigation and piloting tool for both inshore and offshore global navigation must be clearly defined in a step-by-step manner to meet three primary categories: audience needs, technical requirements, and safety regulations and restrictions for travel.
That structured approach is absolutely essential. It forms the foundation for everything else.
So starting with the person on the bridge, how can marine navigation and piloting systems for both inshore and offshore global navigation provide a high-quality experience for the user? What does that really mean in practice?
Well, a high-quality experience now, it really boils down to seamless information flow. You know, the concept of the truly integrated bridge.
Meaning
Continuous, easy-to-understand display of the absolute essentials. Your heading, speed over ground, position, water depth, all right there, probably on the main ECDIS screen, or maybe a dedicated conning information display, the CID.
reducing the need to hunt for information, minimizing that cognitive load, basically.
Exactly. Keep the critical stuff front and center.
And behind the scenes, supporting that smooth experience requires some clever thinking about the hardware setup too, right? I'm thinking about things like KVM systems.
Keyboard video mouse tech. Yes, that's a really smart move.
Because you can take all those noisy, hot computer boxes off the bridge itself, put them in a dedicated server room somewhere else on the vessel.
Directly impacting focus and, ultimately, safety. It seems like a simple thing, but it's fundamental to that quality user experience.
It is. But, while we aim for this sleek, integrated ideal, we immediately hit a snag.
Which is?
Regulatory complexity. The hard truth is that the requirement specification for marine navigation and piloting tool for both inshore and offshore global navigation vary by region, size, and type of vessel, and local laws and situations, weather, events, and tradition.
It's not one size fits all.
That's the perennial challenge, isn't it? Trying to create a global system in a non-uniform world. You've got different GMDSS area requirements, A1 to A4, dictating comms gear based on where you sail. And historical factors muddy the waters, too. Think about the El Faro, built under a MURAD design letter, number 3, which wasn't even a mandatory regulation at the time.
Right. So you're dealing with this patchwork of current rules, legacy standards, local variations. It's a minefield for anyone writing a specification.
It absolutely is. And it means the spec can't just be a rigid list. It has to demand flexibility. The system needs to handle different data packages, adapt regionally.
So dealing with different chart formats, for example, vector versus raster?
Exactly. It needs to ingest and, critically, harmonize data from modern vector ENCs with all their detailed layers, but also still cope with older raster charts where they might be the only option available, and do that safely without glitches when crossing chart boundaries.
Okay, so flexibility is key on the regulatory and data side. Let's shift focus to the core technical capabilities, the engine under the hood.
Right. This system is essentially a digital command center. So the spec has to be clear. Requirement specification for marine, navigation, and piloting tool for both inshore and offshore global navigation. Incorporates existing databases of charts, maps, noting passages, channels, obstacles, depths, traffic, weather.
And it must update maps in the planned course in real time, using satellite feeds, yes, but also crucially, real-time data from the ship's own sensors, GPS, depth sounder, speed log, maybe even current meters, fuel sensors, feeding into the desired course and ETA calculations.
It's all about that data fusion. pulling everything together into one coherent picture.
Which implies stringent requirements for the sensors themselves. Redundancy becomes critical.
Absolutely. For positioning fixing, you can't just rely on standard GPS anymore. The spec needs to mandate differential GPS, DGPS, or similar augmentation
Why specifically DGPS?
to counteract known error sources. Things like errors in the satellite signals themselves, the pseudo-ranges, and critically, the geometry of the satellites, what we call PDO, position dilution of precision. Poor geometry can really degrade accuracy.
So, DGPS for positioning. What about other sensors? Speed logs, depth sounders?
They need to be reliable, obviously, but the spec must also demand standardized communication, using established interfaces like NMEA 0813 or perhaps the more robust RS-422 standard that ensures all these different pieces of kit can actually talk to the central system reliably.
Okay, reliable sensors, standardized interfaces, but this is a global tool. That brings up connectivity, especially in remote waters, which leads to a really practical question. Can we connect to both Starlink type of satellite systems and use library data to relay time update, new geographic region, and new weather data for marine navigation and piloting tool for both inshore and offshore global navigation?
Oh, absolutely. The spec must require this capability now. High bandwidth, reliable satellite communication is becoming the norm, not the exception, even in places like the Arctic.
So using systems like Starlink or similar LEO constellations?
Precisely. The specification needs to clearly define how the system will use these links to get timely updates for charts, geographical data, critical weather forecasts. Think beyond just basic NASTEX, accessing global forecast models, and ensure time synchronization. The data refresh rates need to be fast enough for genuine real-time decision-making. You're listening to OOTO TV with research by author Paul Bulow.
Building on that real-time data theme, there's another layer, vessel performance data, especially fuel consumption.
Yes, integrating engine data and fuel flow information directly into the navigation and piloting tool is becoming increasingly important. It's not just about economy anymore.
It's about compliance, efficiency planning, and even safety, right? Knowing your true endurance. So the spec needs to address this.
Definitely. It should require integration of high-accuracy fuel flow measurements. We're talking about sensors like, say, the Crawl OMP13, which boasts something like 0.1% accuracy across different fuel types, HFO, MGO.
And not just measuring, but recording it too.
Yes, mandatory, permanent data storage for performance monitoring and demonstrating compliance. That needs to be built right into the system specification.
Okay, 0.1% accuracy sounds impressive, but let's play devil's advocate slightly. Is mandating that level of precision with potentially expensive flow meters realistic across the entire global fleet?
That's a fair point. It's the classic specification challenge, balancing the ideal with the practical and affordable.
Could we risk overspecifying here, pricing out smaller operators who'd benefit from the core navigation functions but maybe can't stretch to the absolute top-tier sensors?
It's definitely something the spec writers need to consider. Perhaps tiered requirements or focusing the highest accuracy demands where specific regulations mandate it. But the counter-argument is strong too.
Which is?
Data integrity is the safety margin. If your fuel calculation is off by even a couple of % when you're planning a long passage in a dynamic environment, that could lead to a serious situation. The spec needs to set the standard based on required safety margins, not just minimum cost.
That tension between cost and safety is always there. So integrating vessel health with navigation, that brings us to the broader safety picture. What are key elements for requirement specification for marine navigation and piloting tool for both inshore and offshore global navigation? What really stands out?
Based on incident analysis, I'd say the absolute key element has to be resilience. Resilience against human error and resilience against mechanical or system failures.
Moving beyond just showing where the ship is, to assessing whether the ship can actually survive where it's heading?
Precisely. That's a fundamental shift. The spec needs to mandate that the system isn't just passive. It must actively check the vessel's predicted track against known hazards in the electronic charts, the ENCs.
So, automated look-ahead functions.
Yes, things like the ECDIS safety contour alerts need to be robust and non-negotiable, generating clear alarms for potential grounding situations well before they become critical. It's about building in objective safety checks that work even if the crew is fatigued or distracted.
And we need to embed lessons from specific disasters right into the spec's requirements, don't we?
We absolutely do. Take the El Faro again. A crucial factor in the sinking was the loss of the main engine because the ship listed too far exceeding the design limits for the lube oil system.
So the navigation system needs to be aware of the ship's internal state.
Exactly. The specification must require the system to display the vessel's current angle of inclination and, critically, provide warnings if it approaches or exceeds the design maximum operating angles for essential machinery. It connects external navigation with internal stability and systems integrity.
That's a major step towards holistic vessel management, not just route plotting. What about the human element itself? We know that's often the weak link.
It often is. Look at reports like the Scott Explorer collision, lack of a proper look outside it. Or the El Faro again, where issues with bridge resource management, particularly assertiveness and communication, were highlighted.
So the spec needs to address bridge procedures? How can a system do that?
By mandating highly effective watch monitoring and alarm management systems, going beyond just logging alarms, perhaps requiring active acknowledgments or confirmation loops for critical warnings. It's about using the technology to enforce better safety communication and accountability on the bridge.
Making the system an active participant in enforcing good practice.
In a way, yes. Because we know humans make mistakes, the system needs safeguards. And that inherent fallibility also means the specification can't be a one-and-done document.
So it needs to evolve.
Which means requirement specification for marine navigation and piloting tool for both inshore and offshore global navigation are updated and evaluated on an ongoing basis. Exactly. To incorporate needs and desires for new features and benefits, and crucially, changes to existing regulations and requirements for marine travel. It has to be a living document.
That implies designing for updates and future-proofing right from the start, thinking about modularity?
Absolutely. And anticipating regulatory changes. For example, classification societies like Lloyd's Register are already implementing type approval processes for cyber-enabled components.
So cybersecurity can't be an afterthought for this navigation tool?
Not at all. It has to be designed in from day one, ready for those kinds of assessments. It's a fundamental requirement now, not just a nice-to-have feature.
But again, playing the contrary role for a moment, can we realistically expect a single specification to keep pace? Technology, especially in areas like cyber and AI, moves so fast, regulations and flag state approvals often lag significantly behind.
That's the constant tension, isn't it? The pace of innovation versus the pace of regulation and adoption across a huge, diverse global fleet.
Are we asking the spec to be too far ahead of the curve, potentially creating compliance headaches or making it difficult for older vessels to keep up?
It's a valid concern. The spec needs to be forward-looking but also provide pathways for compliance. But I'd argue it has to lead, especially on safety and environmental fronts.
Like incorporating new environmental tech?
Yes. Things like advanced ballast water treatment systems. The navigation system might need interfaces to monitor their status for compliance. Or consider propulsion. We're seeing innovations like the Peening PCP propeller using water hydraulics to eliminate oil pollution risk.
Or hybrid systems, like the shuttle Y-hybrid thrusters.
Right. The navigation and piloting tool needs the capability, designed in via the spec, to interface, monitor, and record data from these novel systems. It's essential for performance tracking and verifying environmental compliance.
Okay, so let's try and synthesize this. If we boil it down, what are the absolute pillars a robust global nav spec must be built upon today?
I think there are three main takeaways. Drawing directly from what we've discussed, learning from the past, preparing for the future.
Go on. Pillar 1.
Pillar 1 has to be the safety-centric human-machine interface. This isn't just about usability, it's about actively enhancing safety, shifting from just showing position to assessing vessel survival integrity.
Meaning integrated stability warnings, proactive hazard alerts based on the predicted track against the ENC, features specifically designed to counteract known human factor weaknesses identified in accidents.
Exactly. Using the HMI to enforce objective safety measures,
Pillar 2?
Pillar 2 must be hyper-accurate, reliable real-time data. No compromises here.
Right. That means demanding multi-system positioning redundancy, DGPS or equivalent as standard, and mandatory, reliable integration of all key vessel sensors, position, speed, depth, heading, and yes, high-accuracy fuel flow data too, creating a single, trustworthy operational picture.
Okay, safety HMI, accurate data. Pillar 3?
Pillar 3 is future-proof compliance and modularity. The system specification must anticipate change.
So designed from the ground up to be updated, ready for evolving global rules, whether it's cybersecurity type approvals or interfacing with new environmental monitoring systems like ballast water or advanced propulsion.
Precisely. It needs a framework for ongoing evaluation and updates baked into its fundamental design.
So when you pull it all together, this requirement specification, it's far more than just a technical shopping list, isn't it?
Oh, much more. It's really a blueprint for the vessel's operational safety culture and efficiency. It's dynamic, it needs to learn from history, and it has to leverage digitalization not just for convenience, but to proactively mitigate known risks in what's still a very complex maritime world.
It's about transforming those hard-learned lessons into concrete design requirements, a shift from reactive fixes to proactive, system-level safety. We certainly hope our listeners can take these insights, particularly that move from basic navigation towards holistic vessel survival management, and apply them in their own work defining these critical systems. Thank you for joining us on OAOTO TV.
Indeed. Until next time.